target mean encoding with k-fold cross-validation. Usually, mean encoding is notorious for overfitting. Thus, a regularization with cross-validation or some other form of approach is a must in most of the cases. By combining target mean encoding with k-fold cross-validation, we can encode categorical variable while also ensuring that the model is not overfitted on the training data. In k-fold cross-validation, the data is split into k-folds. As you can see, usually, say here, we are dividing the data into 5 folds. And you can see one fold will be validation, while the rest of the 4 folds will be for training. And then in sequence, we will be training one after another, where the second split becomes validation, while the rest of them becomes training, and so on. So this way, we calculate the target mean for the validation fold and train the data using the training fold. And we encode using this process, and this is repeated for all the k folds, which is 4 folds in this case. The advantage of this is it reduces overfitting through cross-validation. It also improves the performance on new unseen data. Doing it for k times, which is more computationally expensive. Let me go through with our example to explain this. So we have the dataset with temperature and color, 10 rows. This is ordinal, this is nominal. We have hot, cold, very hot, and warm. Here we have red, yellow, and blue as categories. Now, what we can do, one way is we have split it into 5 folds. 1, 2, 3, 4, 5. For explanation purpose, I am just using 0, 1 as 1, but usually it will be randomly set, which means 0 could be in 1 and 8 could be in 1. And it depends on the setting that we'll do at the time of training. Now, in this first case, we may use the training using the fold 2, 3, 4, 5, and validation will be 1, which means these all data will be setting as mean for target, and then whatever values we are getting, we'll be applying this for these variables. So if you see here, we will just take example of temperature, how it is calculated. If you see for this scenario, temperature category has cold, hot, very hot, and warm, and the count wise cold is 1. So you can see for these 4 folds, there is only one cold, which is this one, and target is also 1. So sum of the target is also, we can see 1 and 1. Similarly, if you see for hot, it is 1 hot here, 1 hot here, 1 hot here. So total 3 hot, and the target is 1 here and 1 here, which means 2. That's how very hot and warm we have count and target sum. Now if we calculate the mean, this will be 1, this is 0.6667, 1, and 0.333. Now these values will be assigned to our encoded temperature field. So we'll be encoding this hot and cold after this computation. So hot and cold, hot is 0.6667 and cold is 1. So that's how you can see after encoding, hot will become encoded like this, cold will be encoded like this. Then this will be repeated again and again. Next time 2 will be validation, and 1, 3, 4, and 5 will be training. And that's how whatever value we get will be updating this very hot and warm. Target mean encoding with k-fold cross-validation. Here, other than pandas and numpy, I am importing sklearn model selection, and I am importing the k-fold because we need the k-fold cross-validation. I have created one function called target mean encoding k-fold. What it takes? It takes one data frame as input, categorical column that we want to encode, the target column from the data frame, and the number of splits. Here, by default, I am using 5 splits. So how the function works is, first, we are creating an empty column to store our indexes. Because once we create the k fold, we have to run through based on this index and apply after training into the validation set. We initialize the k fold in this k variable with the number of splits. We are setting shuffle as true and random state equal to 4. Why I have used 4? Just to replicate the exact example that I have run through the explanation. Now, what we'll do, we'll run in for loop as I have shown, like all the folds, 5 folds will be running one by one. And we are setting the train index and validation index. If you remember our example, we set the first fold as the validation and rest all other are training. So here, when we are running this for loop, first occurrence will be exactly the same scenario. So we have train and validation, and the KF split based on the data frame, we are splitting it. Since we have 10 records and we have set the split at 5, there will be total 8 indexes in training and 2 in validation. So first, based on this index, we split the data into train data and validation data. You can see we are using the whatever we have got from here, the index. We are using the index location of the data frame to select the train index and select the validation index. Now, exactly the same way we did for mean encoding, we'll be running the training data and we'll be creating the mean by grouping each categories in the training data, and based on target column, we'll be calculating the mean for all these training data categories. After that, we'll apply whatever values are calculated here into the validation data. You can see here validation data, we are just mapping it, the target mean. And what we are updating? We are updating the data frame with this index location of validation index, as I have shown while running the example. Now this will run 5 times and all the rows will be updated. One interesting fact is, we may have scenario where we can face a divide by 0 scenario where there may not be any value available, or it may be a scenario where the numbers we are not getting in the training and we have a validation set, we have one category which is a new category. So in those cases, one approach could be we can straight away set it to 1, or another way could be we take a global mean. So here I am calculating the global mean. If there is not a number in the encoded data, I can use the global mean to replace those not a number. Now data frame is loaded using our toy dataset. Then I am applying the encoding for columns which are temperature and color, and I'm still keeping the number of split as 5. After encoding, you can see this first 2 is the temperature that I have shown in the example, and you can see it's matching exactly. That's all for this video. Thanks for watching. Don't forget to like, share, and subscribe for more exciting content on machine learning and AI.